Alright, so we need to find the equal point, where we need to find the magnetic field for each of these two wires, add them up and see where they're equal to 0. So let's consider, if you use the right-hand rule here for I1, you find that the magnetic field due to I1 over here is into the page. It's out of the page over here. Okay, so there's B1 and B1. For I2, the magnetic field is into the page on this side and out of the page on this side. Okay, so there's B2, B2. Okay, so that tells us that in here, it's not possible for the magnetic field to equal 0 because both magnetic field components due to B1 and B2 point in the same direction, so they can't cancel out. Now over here on this side, B1 points out of the page and B2 points into the page, so that's a possibility. However, if you consider, what if I tried to set B1 equal to B2? Okay, and let's say that, this distance R1, and then, okay, so I would have mu naught times 5 over 2 pi R1 is equal to 2 pi times 2 over R1 plus 0.6. So the right-hand side of this equation, the numerator is smaller, and the denominator is always going to be bigger, right? And so that means this whole thing, this whole right-hand side, no matter what, is always going to be smaller. If you're really close to I1, then this is going to be smaller. If you're really far away from I1, then this is going to be smaller. So over here is out. Got to be over here. Okay, generally speaking, we want to be closer to the smaller current, so that the smaller distance can partially compensate for the smaller current. Alright, so if I'm going to be somewhere over here, then I will call that distance R2. Okay, and so my equation is going to be mu naught times 5 over 2 pi times R2 plus 0.6. That's equal to mu naught times 2 over 2 pi R2. Okay, and then mu naught over 2 pi goes away, and I'm left with 5 over 2 is equal to R2 plus 0.6 over R2. And so that gives me 5R2 is equal to 2R2 plus 1.6. 3R2 is equal to 1.6. Wait, 1.2. I'm sorry. A mathematical error there. 2 times 0.6 is 1.2. Yeah, so that gives me R2 is equal to 0.40 meters. Okay, so we're 0.40 meters from R2. If you instead solve for the distance from R1, then that would be 1.0 meters, because this is 0.4 meters. Okay, so there's your answer.